we need to determine if this conditional statement is a true or false conditional statement. So here it says, if an odd number is divisible by 2, then 8 is a perfect square. So refer to the truth table. There's only four truth values. It could either be true or false. And these are the situations you can have. So my hypothesis could either be true or false, and the same thing for the conclusion. So I can have either true and true, true false, false true, and false false. Those are different situations for the hypothesis and the conclusion. And then for the conditional itself, well, if I were to make a conditional out of this hypothesis and conclusion, I can get true with true, true with false, false and true, and false and false. So my truth value, the only time a conditional statement is false is in this case when you have a true hypothesis and a false conclusion. So every other case is going to be true, and this is the only time that it's going to be false, when your hypothesis is true, conclusion is false. And now we have to see here, if an odd number is divisible by 2, and then then A is a perfect square. So if I look at this hypothesis, if an odd number is divisible by 2, to be divisible means you can rewrite that number as the product of 2 and some other number. So an odd number, so for instance, think of any of the odd numbers like 3, 5, 7, 9, 11, 13, 15, 17, 19. So these are all odd numbers. Can you rewrite any of these numbers as the product of 2 and some other number? Or in other words, is 2 a factor of any of these numbers, or any odd number you could think of? Well, the answer to that would be no. So this hypothesis is actually false. And since I have a false hypothesis, these are the only two cases here when the hypothesis is false, and I can see the outcome for each one is going to be true no matter what the conclusion is. So once I know that my hypothesis is it cannot be true at all, because these are examples, right? We know that odd number is not divisible by 2, because to be divisible by 2, you have to be able to rewrite that number as the product of 2 and a number, or in other words, 2 has to be a factor of one of those numbers, right? Like for instance, just so to be clear, a number such as either like 2, 4, 6, 8, 10, 12, 14, 16, 18, right? Any of these are even numbers. You could always rewrite these numbers as, 2 times some numbers. So this is 2 times 2, this is 2 times 3, this is 2 times 4, 2 times 5, 2 times 6, 2 times 7, 2 times 8, and 2 times 9. So that's why the even numbers are divisible by 2, because you could rewrite these numbers as the product of 2 and some other number to get back to each result. But for odd numbers, you can't do it. That's why these are not divisible by 2. So therefore, this is a false hypothesis, and the overall conditional statement has a truth value of true.